All right, greetings geometry students. Hope you're having a good weekend. I appreciate you finding time in your busy schedules to get your notes taken care of. For Monday's class, we're going to be looking at another foundation principle for all triangles, and this is an important one. It's called the triangle inequality theorem. So let's have a look at it. Our objective will be the student will learn the applications of the triangle inequality theorem. These notes are for Monday, November the 4th, so copy your objective and the date. And as always, press pause anytime you need more time and hit play when you're ready to move on. Now this objective talks about the applications, plural, because there's actually a couple of different ways to apply this theorem, and you will be expected to know both ways to apply it. Okay, so let's take a look at the theorem. The triangle inequality theorem says that any two sides of a triangle must be able to add together to be longer than the length of the third side of the triangle. Okay. Now this actually applies three different ways. Okay, obviously you have three different sides. So by the letter of the law here, that side A and B must add together to be larger than the length of the third side, C. Now, of course, keep in mind with the little greater than or less than signs, I'm sure you remember from your days in junior high, the sign, the big side of the sign points toward the big side of the big value in the problem. The small side points towards the small side. Okay, or maybe you learned the alligator mouth thing. The alligator's eating the bigger amount. Okay, however you learned it. Okay, but so side A must add together with side B to be greater than side C. Side B must add together with side C in order to be greater than side A, and side C must add together to be greater than side B. Okay, all three of those have to be true in order for a triangle to actually be a triangle. Now you may ask yourself, why on earth would we be studying the triangle if it wasn't even a triangle? Well, you might be surprised. Sometimes the tests we see do try to trick us by giving us three values that actually are incapable of being a triangle. So we got to watch out for the triangle inequality theorem. Okay, so let's take a look at the background behind this rule. Okay, let's have a look at why it is true. For a moment, let us assume that it might be possible for two sides of a triangle to add together and still be smaller than the length of the third side. Okay, so an example of that might be a triangle that has side lengths of 4, 5, and 10. Now, without considering the triangle inequality theorem, it seems reasonable that you could have side lengths of 4 and 5 and 10. They're just numbers after all. Why couldn't they possibly be the lengths of the three sides of a triangle? Okay, well, let's have a look. The triangle inequality theorem tells us that any two sides must add together to be larger than the length of the third side. Well, mostly we are concerned that the two smallest sides will add together and somehow not be larger than the length of the third side. So in this case, we're worried that the 4 and the 5, okay, must add together, and the triangle inequality theorem says that that must be bigger than 10. Well, obviously it's not, but let's see what the big deal is. Okay, so we have a situation where the triangle inequality theorem is not true. Okay, so look at the following diagram. Okay, these line segments that are provided in the picture for you, okay, they are actually drawn to scale. So the blue line segment is actually 5 units long, the green one is actually 4 units long, and the red one's actually 10 units long. And if we connect the blue and the red together at a vertex, and the green and the red together at a vertex, look at what's trying to happen between the green and the red, or the blue and the red, green ends of the triangle. They can't even reach each other. Okay, so this is going to cause a fundamental problem. Clearly, there's not enough length for the sides to enclose the figure. As a result, we cannot say that this is a triangle, and we can't even say that it's a polygon at all because it's not an enclosed figure. That's part of the definition of being a polygon, built out of line segments and enclosed. Okay, so if it's not even a polygon, definitely not going to be a particular type of a polygon. And we'll have a closer look at examples like this in class on Monday. Okay, but we do have several examples that we need to look at because there's a lot of different things to consider here. Okay, so let's look. Is it possible for the following lengths to form a triangle? And we're provided with three lengths, 3 and 4 and 5. Okay, so copy this down. The triangle inequality theorem, once again, you've already got this written down, so you don't need to write this sentence again. But any two sides must add together to be longer than the length of the third side. Okay. Well, that puts us in a situation where three things must be true. There's three different ways to add up these three different side lengths, taking them two at a time. Okay, 3 plus 4 needs to add up to be larger than the third side, which is 5. 4 plus 5 must add together to be larger than 3. 5 plus 3 must add together to be larger than 4. Okay, so let's simplify this a little bit. Okay, obviously 3 plus 4 on the left side is going to be 7. 4 plus 5 there in the middle is going to be 9. And on the right side, 5 plus 3 is going to be 8. Okay, so on the left, we have a statement that says 7 is larger than 5. Is this true? Well, of course it is. In the middle, 9 is greater than 3. Is that one true? Yes, it is. And on the right side, 8 is greater than 4. Is that true? Yes, it is. If we have truth in all of these statements, then we are able to say, yes, these lengths can form a triangle. All right, another example on the flip side of this, okay, again, same question, so you can probably get away without writing the question down again, but here are some new lengths, 9, 12, and 2. Okay, well, the same situation is going to be true. All of the following must work. Okay, we must be able to add together 9 and 12, which must be greater than 2. We must be able to add together 12 and 2, which must be greater than 9. And we must be able to add 2 and 9, which must be greater than 12. Okay, well, let's take a look at the math. On the left side, 9 plus 12 is 21. In the center, 2 plus 12 is 14. And on the left, or the right side, pardon me, 2 plus 9 is 11. Okay, so our statements say 21 is greater than 2. Is that true? Yes, it is. In the middle, 14 is greater than 9? Yep. And on the right, 11 is greater than 12. Uh-oh, that one's not any good. Okay, if we come up with any one false statement, then that is going to force us to think that the entire problem is false. So since one of these did not turn out correctly, the entire problem is bad. So the answer in this case would be no. These lengths cannot form a triangle. Let's look at one more example on this before we move on. Let's consider these lengths, 11, 5, and 6. Okay. Well, once again, by the triangle inequality theorem, 11 plus 5 must add together to be larger than 6. 5 plus 6 must add together to be larger than 11. And 6 plus 11 must add together to be larger than 5. So let's simplify. In the center, or the left side, pardon me, 11 plus 5 is 16. In the middle, 5 plus 6 is 11. And on the right, 6 plus 11 is 17. So let's check our statements. On the left, 16 is greater than 6. Sure is. Looks good. In the middle, 11 is greater than 11. Well, that doesn't seem quite right. The right side says 17 is greater than 5. That's certainly true. But in the center, 11 is not greater than 11. It is not good enough if it happens to be a tie. The theorem says that the two sides must add together to be larger than the length of the third side. So I gave you this example just to show you what would happen if indeed you did have a tie with the triangle inequality theorem, and that one does not work. Okay, now there is another way that the triangle inequality theorem can be used, and it's a little bit more involved, so let's take a look at it. Okay. This theorem can be used to determine possible lengths of an unknown side. Sometimes we will be given two side lengths of a triangle, and then we will be asked what is possible or what do we know about the third side of the triangle. Okay, so for example, if a triangle has side lengths of 5 and 7, what can be told about the length of the third side? Okay, well, as you can tell, what's happening with our figures here is they're giving us less and less and less information, but they're still asking us to know something about it. Okay, but let's have a look. Okay. The triangle inequality theorem says any two side lengths must add together to be larger than the length of the third side. We know this because we've already talked about the theorem and we worked 3 examples of it. The theorem, okay, is pretty straightforward. But this time we have an unknown side length, so let's just call it x. Using the two values that we do know and the triangle inequality theorem, that means that 5 must add together with 7 to be larger than x. But also 7 must add together with x to be greater than 5, and x must add together with 5 to be greater than 7. Okay, well, in this case, we're going to simplify, but that may mean that we have to move some things around. On the left side, x is already isolated. We can just add together the 5 and the 7 and get 12. In the center, we would like to get the 7 away from the x, so we're going to have to subtract 7 from both sides. On the right side, we're going to have to get the x by itself, and so we're going to have to subtract 5 from both sides. Okay, so doing that algebra with this next step, on the left side, we're going to have a 12. In the center, 5 minus 7 is going to be negative 2. And on the right, 7 minus 5 is going to be positive 2. Okay. So our statements are 12 is greater than x is greater than negative 2, and x is greater than positive 2. Now, one of these values ought to be a little concerning to you, okay, and it is the one in the center, okay? What we have is we have a side length of a triangle that is being compared to a negative number. Are you going to have negative side lengths for any polygon? No, it's okay to have a negative variable in a problem, but the entire side length can't end up being a negative number. There's no such thing as a negative side length, so when you do the triangle inequality theorem this way, you are going to have to disregard the one that kicks up a negative value. So we're only going to worry about the x and the x being smaller than 12 and the x being larger than 2. Okay, so let's focus on those. Okay. Now, the easiest thing for people to do to get a grasp on this solution is to place your results on a number line. Okay, 12 is going to be one of our points on the number line. 2 is going to be another point on the number line. Okay, so simply mark those values, and if we've done our math correctly, these values ought to be pointing at each other. Okay, Okay, the blue one on the left says x is smaller than 12, or 12 is larger than x. Either way, that means x should be to the left of 12. The purple one on the right says x should be greater than 2. That means that x is going to be to the right of the 2. So we have these two values that are pointing at each other. That means that x must be somewhere in between 2 and 12 on the number line. Now remember, it cannot be a tie with one of these numbers. So x cannot be 2, x cannot be 12. So when it comes time to answer our question, we will make sure that we note that it is somewhere between 2 and 12. Okay, and the proper notation is like this. 2 is smaller than x, but x is smaller than 12. So our value for x must be somewhere between the number 2 and the number 12, the length of 2 and the length of 12. Okay, it's not as difficult as it seems. I'm going to give you a couple of more values and ask you to give it a try on your own. Okay, and here you are. A triangle has side lengths of x, 7, and 15. Actually, I'll go ahead and work through this one with you, and then I'll give you one more after this one. X and 7 and 15. What do you know about x? Well, once again, by the triangle inequality theorem, any way that we can add up two side lengths, that sum has to be larger than the length of the third side. Okay, so these three things must be true. X plus 7 must be greater than 15, 7 plus 15 must be greater than x, and 15 plus x must be greater than 7. On the left side, we need to isolate x, so we're going to subtract 7 from both sides. In the center, x is already isolated, so we're just going to add 7 and 15. And on the right side, we need to isolate x, so we would be subtracting 15 from both sides. Okay. On the left equation, 15 minus 7 is going to be 8. In the center, 7 plus 15 is going to be 22. And on the right, 7 minus 15 is going to be negative 8. Obviously, we are going to disregard the right-hand equation, x is greater than negative 8, because we know that we cannot have a negative side length. So the left-hand equation and the center equation are the ones that we're going to look at, and we're going to place them on a number line, make sure we understand. 8 is going to be one of the points on our number line. 22 is going to be another point on our number line. We will shade upwards from the 8 because it says x is greater than 8. Okay, and we will shade downwards from the 22 because 22 is greater than x, means x is smaller. So in the end, x must be a value that is between 8 and 22. 8 is smaller than x, which is smaller than 22. Okay, here is the last one that you are getting. I apologize for the notes being a little bit longer than usual, but it does take some examples in order to get a good understanding of the triangle inequality theorem. I want you to copy this one down. I want you to give it a try in your notes. Okay, keep in mind that trying the examples that I tell you to try, that is part of having completed notes. And if you don't give it a try, then I might count your notes as not being complete, so please do it. A triangle has side lengths of 5 and 5 and x. What do you know about the length of the third side? Copy it down and use the previous examples as a template for how to do this. And let's see what kind of an answer you can come up with. And we will have a look at it in class together on Monday. I appreciate you taking time out from your weekend. I hope you're having a good and safe weekend, and I will see you back in class on Monday.